Alright, today we're going to talk about metamorphic rocks. First concept is how are metamorphic rocks formed? They're formed due to pre-existing rock that gets extreme heat and pressure due to burial. As they go further down towards the heat source, which would be the mantle, they tend to change form and turn into metamorphic rocks. As it shows right here, when we go through the cycle, as we go increase heat, it says increase metamorphism, but more so this is increasing heat. You start off with shale, which is a sedimentary rock. Let's highlight that right there. And then it's going to turn to slate, then to phyllite, then to schist, then to gneiss, in that order. If it were to completely melt, we would call it an igneous rock, not a metamorphic. So what is the difference between contact, and regional metamorphism? Regional, if you take a look here, is going to be over a large area, so that's going to be something that's underneath the mountain. So if we were to draw a mountain right here, you would find the regional right about here in this circled area. Contact is more like the lava coming up. So let's take that same mountain, but we'll call it a volcano this time. And then if you look, all along the edges of the lava coming up, that's where we're going to find the contact metamorphism. And that's where we're going to end up with metamorphic rocks, which is right here where I'm coloring in. It's also a great place to find diamonds. Regional, if you take a look, here's a picture again. If you notice, we've got mountains right here, and due to convergence, due to plates, this heat source right here, then we've got the pressure formed right there. That's going to ultimately cause us to have this, which is these wavy lines, which is the metamorphism. Here in contact, this is a cross-section that you'll see later when we talk about geologic history, but these little whiskers here, as we call them, is where the contact metamorphism is going to be. So you could take a rock like this one here, which are these bricks, which is limestone, and right here where I'm circling at that site, it's going to become marble, because that is what limestone metamorphoses into. Here we've got conglomerate, and that's going to become metaconglomerate. Here we've got shale. Shale is going to Shale is ultimately going to become slate. How to identify metamorphic rocks? There's either foliation or they're non-foliated. Foliation means that the minerals are either going to be aligned in layers or become distorted, like banding. Non-foliated is basically the minerals are melted, partially melted that is, and then you're going to see them with the non-distinct pattern, something like marble or quartzite. Here's an example. Here with this piece of gneiss, you see you got the wavy bands. It looks like zebra stripes is the best way to think about it, so I always say zebras have nice stripes. Mineral alignment, we're going to get these layers here that are caused by the minerals basically being flattened out. And then finally, here's the scheme. We've got our foliated right here. Give me 1 sec and I'll highlight those. So here's going to be our foliated, right along here. And then our non-foliated will be the next one right up here. So let's delete that box so you can see what we're doing. Now, if you take a look, the foliated, here are the two different varieties. You got mineral alignment and you have banding. And as I said before, regional, as you increase heat, you get the different rocks. So more heat, more metamorphism, you get a different variety of rock. Non-foliated, the important thing to note about that is to take a look at the parent rock, which they show you right here. Sandstone, dolostone, and this would be from conglomerate, which is where it says pebbles. And then hornfels is a bunch of different rocks, so there's no one distinct rock that will tell it. And then when it talks about composition, this is why hornfels is difficult to identify, because it is variable, where the other ones are very specific.